Flack math! Give me some math and I'll give you some flack. Flack math!
Lesson 10, here we go. So we talked about inverse operations. Inverse operations kind of undo each other. So for example, 5 times 3 divided by 3. Well, you don't really need to do that math, right? You don't need to multiply by 3 and then divide by 3 because you know that they're going to undo each other and you're going to end up right back at 5, okay? So inverse operations. Inverse operation of multiplication is division, right? Inverse operation of addition is what? Subtraction. Do you guys know what the inverse operation of squaring a number is? Triangulate. Nice. Not like literally with a shaped square. But how do you do that backwards? How do you undo squaring something? What? So unsquare it. But there's such a thing. When you square 3, 3 squared is 9. How do you get back to 3?
Oh, yeah.
Not divide.
No, it's like the one thing where you like.
Can't think of it at 8:15 in the morning? No.
Subtraction.
No, come on. How do you get from 9 back down to 3? Wow. Maybe 3.
I don't remember the name. It's like the thing where you.
It's the thing.
It's the thing where it
3
looks like
squared equals 9. 9 square rooted.
Oh my gosh.
3.
Yeah, I knew
Taking the
I knew
square
what it
root.
looked like. I'm like, what's it called?
I know. I felt the correct answer in the air around your head, but it was just not connecting. Okay. So those are just examples of some inverse operations. Okay. Now, we talked about 3 times 2 equals 6. So if I want to go backwards, I go 6 divided by 2 equals 3, or 6 over 2 equals 3. So that's an inverse operation. Now, let's look at this division problem. 6 divided by 0. How many times does 0 go into 6? Or what do you multiply by 0 to get 6? What? That's a great answer. There's nothing. You can't multiply anything by 0 to get 6.
Trick question.
It is kind of a trick question. It's not even a question. There's like, we call this undefined. Right? Because 0 times what equals 6? Nothing. There is no real number that exists that you can multiply by 0 to get 6. Okay? Infinity doesn't work. Infinity times 0 is still 0. All right? So this is one weird answer in algebra. So now from now on, you have to be conscious of what's in the denominator or what you're dividing by. Okay? What about this? 0 divided by 0. What's that? Can you multiply 0 by something to get 0?
It's 1.
Okay. Well, 0 times 1 equals 0. But look what else. 0 times 47 equals 0. So this could be 47.
Also could be infinity.
It could be infinity. It could be any number at all, but the same thing over itself is usually 1, right? When you divide the same thing by itself, it's usually 1, unless it's 0. So this is not, we don't call it undefined, we call this indeterminate. Because it's impossible to determine what the answer is, because there's so many that we could choose. But they're inconsistent, right?
Kind
looks like an infinity sign.
It does kind of look like an infinity sign. Okay, and it could be 0. 0 times itself equals 0. That's a legit multiplication problem. 0 times 0 equals 0. Okay, but this is a no. So these two math problems are like, they bother me because they're like the exception to so many rules. It's impossible. I used to have a poster in my room, the 10 Commandments of math, and the first commandment was, "Thou shalt not divide by 0." It was a clever poster. I liked it. I don't know what happened to it, but I'll have to find it. Yeah, so you can't divide by 0, and you can't divide 0 by 0. Now, this is okay. There's only one answer to this. What times 6 equals 0? 0. So you can have 0 on top, you just can't have 0 on the bottom. Okay? And not only so you're looking for this, but if you happen to have 0 on both top and the bottom, then that answer is different. That's indeterminate. You're going to get a lot more of these answers than you are these, but sometimes you'll get 0 both on top and the bottom. Now, you're not going to get a problem like this. You're going to get a problem where you have to work out everything on top, work out everything on the bottom, and if you're left with a 0 on the bottom or top, then you have to determine the right answer from there. Okay? So write down these 3 things. So 6 divided by 0 is undefined, 0 divided by 0 is indeterminate, 0 divided by 6 is 0. So if you can remember those 3 answers, then you can do these problems, all right? Or do as much as you can before you have to give a lame answer like that, all right? So here's some examples of what you might see in your homework and on your test. Here's example 1. 4 minus 2 all over 13. What's the answer to this problem?
0 divided by 13.
Yep, so you get 0 on top divided by 13. Which category is that? What answer? What's my answer?
0.
0. That's okay. That's a good one. Okay, let's do another one. Example 2. Well, that's boring. What's that going to be?
Undefined.
Undefined, because you're going to get 13 over 0, and then that alarm is going to go off in your head saying danger. That's bad, right? And so that's just any number besides 0 divided by 0 is undefined. Okay? Does that make sense? It shouldn't make sense, but does it make sense? Okay, and can you guys figure out when to write undefined and when to write indeterminate? Does that make sense? Okay, good. All right, so the last part of this, actually let's do a few more. We talked about the commutative power. Did we talk about the commutative power of addition and multiplication and stuff like that? The commutative property. Do you know what the commutative property says? 5 plus 3 does equal 8, but commutative property says you can switch it. 5 plus 3 equals 3 plus 5. So commutative property means you can switch it. So that works for multiplication as well. Commutative property of multiplication. 4 times 3 equals 12. 3 times 4 equals 12. Right? Well, it's the same with signs. So -4 times 3 equals 12. 3 times -4 equals 12. Because the same rules apply, unlike not 12. You guys got to be on your game. You could have gotten a free problem set if you.
What about like
Caught that.
-4 and -3 times each other equals +12?
Yeah. So the same rules apply. Unlike signs negative, these are still unlike signs. It doesn't matter what order they're in. It's negative. Okay? So you can really change the order however you want. So here's another example. Let's try a few more of these. -4, parenthesis 3, parenthesis -6, parenthesis -2. So remember, these are not subtraction problems. Those parentheses just surround the number. So you're multiplying 4 things together. So how do you want to multiply these 4 things together? What do you want to do? Just go left to right? What are you thinking?
Multiply the negatives and multiply the positives.
Okay, you can do that. So you get -4 times -6 is positive 24 times a -2 is -48. Okay, times 3, let's see, I think that's 144. Wait a minute, was it a -48 or a positive 48? So that's a lot to do in your head because you're doing 2 things. You're doing the arithmetic, which means you're multiplying the numbers, but you also have to keep track of your signs. Well, do you guys know what the answer to this problem is going to be? Is it going to be positive or negative? Negative. Why do you know that? There's an odd number of negatives. Remember, it doesn't matter how many positives you have, it's all about the negatives. Which is sad, but true. So you can literally just take all the negatives out of there and just go negative, negative, negative. And then it's just 4 times 3 times 6 times 2. Okay, so -144. It's not bad. So don't try to go, okay, -4 times 3 is 12, and then negative times a positive negative. Okay, so -12 times -6. -12 times -6. So it's a positive because it's a negative times a negative. 12 times 6 is 72. Okay, 72. So see how that's a lot more work when you have to worry about the negative signs. So just deal with the negative signs and then ignore them. You know your answer is going to be negative, and then just plug that into your calculator or into your calculator. 4 times 3 times 6 times 2, and you already know it's negative, so it's -144. Okay? Does that feel all right? You'll get a lot of those in your homework. I'm not going to do any more. But one question that you will get on your test, probably your next test, I think the first or second question will say, what answer do you get when you multiply 11 negative numbers with 7 positive numbers? So what's your answer going to be? Is it going to be positive or negative? Negative. Remember, it's always just, they throw in that number of positive numbers to try to trick you, but don't. It doesn't matter how many positive numbers you multiply, it's all about the negatives. Okay? All right, one more part to this lesson. We're going to talk a little bit more about converting measurements again, but this time we're going to convert area measurements, which means we're adding another dimension. So see if you can answer as fast as you can. How many square inches are in 2 square feet? Go. 24 is what most people say. That's why I say go as fast as you can, because I wanted you to mess it up. Okay? But it's not. Think about a square foot. Okay?
Oh my gosh.
Think about like a tile in your bathroom. Usually those are like square tiles, right?
288 feet.
288 feet is the square inches is the right answer. So if this was a square foot,
Is it 96?
no. This is a square foot. This is a 12 inch by 12 inch tile, right?
Oh.
Well, what's a square inch look like? That's this guy right here. So how many of those, this is not going to be drawn correctly, but you get the idea. So we have 12 rows of 12. So how many square inches are in a square foot? 144 square inches. Okay? So if it's 2 of these, it'd just be 2 times 144. All right? So it's not the first answer that comes to your mind. So you have to slow down when you're doing these conversions in area. And I think it's fine to do this by just multiplying or dividing by 144 when you're converting from square inches to square feet or square feet to square inches. The same rules apply. When you go big to small, it's multiply. When you go small to big, it's division, right? But you could use unit multipliers. Let's try an example. Let's try 44 square inches equals how many square feet? Well, remember the steps to unit multipliers. First one, write first measurement over 1. Don't forget the label. So with the label, because that label is the most important part of converting with unit multipliers. Okay? So number 2, what's the second step to unit multipliers? Do you remember?
Put something that cross cancels out.
Yeah, multiply by a unit multiplier that will cross cancel the first label. Okay, well, it's still going to be inches, but how many of those inches labels do you see? Remember that square means it's times itself, so x squared is like xx, right? Well, this is just inches, inches. Okay, so when you multiply by, let's see, it'd be 1 foot over 12 inches. When you multiply by one of those, it's just going to multiply, it's just going to get rid of one of them. So that squared can be like 44 inches, inches, because inches, inches is like inches times itself. So this only cross cancels one of them, right? So we need another one. We need to multiply by another one because we have another inch label to get rid of. Times another 1 foot over 12 inches, and this will get rid of that. So then your final answer, 44, that all canceled out, times 1 times foot times foot. What's feet, feet? Square feet. All over 12 times 12, which is 144, so you can reduce that if you want to, or you can just write it out or figure it out on your calculator. But that's it. Okay, and your answer in your back of the book might keep it like this, or might keep it like that, or it might do a little bit of the math. What goes into 22, 72, 11, 36. So it could look like this, or you could probably get you a decimal number or something. That's what they have. Okay? And that wasn't the problem in the book. Let's try something else. So here's the final thing I'm going to do. But if you want to do more, there's more practice problems we can do together. But let's convert 44 square inches to square centimeters. Okay? So first step, what's the first step? What's the first step? Yep, throw it over 1. So inches, inches. You don't have to write it out like that, but it's a good way to remember. Good reminder that you need to multiply by 2 unit multipliers now. Okay, so now what unit multiplier has inches in it, but gets me closer to centimeters?
1 inch
Over what?
centimeters.
Yeah, so what's that? What's that number? So what are we looking for? 2.54. Is it 2.54 inches in a centimeter or 2.54 centimeters in an inch?
2.54 centimeters.
Okay, so what goes on top? The centimeters or the inch?
Centimeters.
Yes. Why?
Because you're multiplying 1 inch into 2.54 centimeters.
Yep.
Or
But
because you
why-
have to cross cancel.
Yeah, so now you can cross cancel. Okay? But see how that's only going to get rid of one of them. We still have another inch label. Okay? So multiply by 2 of them, by another 2.54 centimeters over 1 inch. And that'll cancel the other one. So now you're done with those labels, and now you're stuck with this. So here's how you can write your answer. 44, parenthesis, 2.54 times another 2.54. What's the quick way to say that? Yeah, let's just put an exponent there. That means we're multiplying by 2 of them, right, by itself. And then centimeters, so centimeters squared, all over 1. So when it's all over 1, you can ignore the bottom, right? So then this could just be your answer. And you can leave it like that. I think the back of your solutions manual, did I say back of your book? In the old days, that's where they used to put the answers and just the odds. They might still have those in there. I don't know. So in your solutions manual, probably have it like this. They won't multiply it out. And I know it's weird, but I know you know how to do the rest of this. If you wanted to give me an actual answer, and if you were legitimately wanting to know how many square centimeters 44 square inches was, you were doing some kind of project or something, then yeah, give me an exact as you can answer. But this is how they're gonna leave their answers, which is kind of weird, but less work for you. Okay? Does that feel all right? Do you guys want me to do some more of these, or you feel confident that you can do these? Okay? Good. All right, so the conversion factor here is whatever 2.54 squared is, because if you think about an inch, it's 2.54 centimeters by 2.54. If this is a square inch, then you just figure out how many square centimeters are in that square inch, just multiply 2.54 times itself. Okay? And that's a conversion factor. So you don't have to do unit multipliers, but again, if you do unit multipliers, I'll give you a little bit of extra credit on the test if you do that. There weren't any like that on the test, were there? Yeah, it was all. But the next one there will be. All right. You guys good? All right.
Black math, give me some math and I'll give you some flack. Black math.